Okay, so today we'll talk about the Hbase database, which is a NoSQL database, and what is its architecture, how it's related to the other technology stack or ecosystem projects that we have at Hadoop level. These are all other, I'll say, complementary technologies or products which are around Hadoop, which tries to offer some or other alternative. With Apache Pig also we have seen it gives you a flexible workflow language. Hive gives another type of language to write your map reduce job, mostly your Hive QL and all, which is very similar to your SQL and all. Hbase will not be giving you anything at a excuse me, at a map reduce type of level, but it does offers you an alternative to store the data in a manner which can be accessed randomly. So this kind of act as a storage for your data and act as an alternative to your HDFS and all. And if you want to construct I'll say complex Hadoop based interaction systems, you can club Hbase, Hive and that type of individual products and build it to their specific needs. So let's go ahead and get started on Hbase. In its core, Hbase is again an Apache project. It is inspired from Google's Big Table white papers. We have seen that the previous other technologies around Hadoop, its HDFS file system as well as the MapReduce framework, they all come from those research papers. Hbase also has its origin. So Google's Big Table is the paper from which contains the core of it. It's an open source distributed sorted map data store modeled after your Google Big Table. So that's something again is managed by your Apache Foundation. As with other Apache projects, this is an open source database and you have all the different types of people, those who contribute to it from different companies. You will have that skill sets and also this is different as we said that this is a kind of a NoSQL type of database, and in that sense it's different from your traditional approaches of RDBMS, which goes on dates cardinality principles and those type of rules. NoSQL database need not necessarily follow those type of considerations. Their purpose is different in terms of storing a large amount of data and giving faster access to their data, but that comes with a trade-off which you have at traditional RDBMS level, in the sense you might not get that complex level of or elegant level of transaction handling, concurrency support, as well as at least at Hbase level you don't get a very strong query language to do that type of processing. So needs are different, and that's where you see that both your traditional RDBMS also has its place, as well as your NoSQL databases like Hbase do serve the purpose. Hadoop in turn can integrate with your traditional databases through technologies like Scoop, which can read from your PostgreSQL, MySQL or even Oracle database and put the data into HDFS, which in turn can be used for map reduce jobs. Hbase in that sense acts as an alternative in the sense that you can store the data directly in Hbase and have your map reduce jobs point to Hbase as a location to get the input for the jobs. In its core, as we talked about, it's not a relational database. I think some of you, or at least every one of you at some point of time, have some interaction with your RDBMS, Oracle, DB2, SQL Server. All those are the traditional databases which we use either in J2E, .NET, Open System. They are relational databases and all, but your Hbase, it's a NoSQL database. And these days that NoSQL and all has come very heavily in the market, so you will see lot many alternatives around that. Google, Big Table, Cassandra, as well as your DynamoDB from Amazon, are some other alternatives around that one, all inspired on that basic concept of NoSQL. You can see that it internally contains, see the table will consist of rows, each of which has a primary key, what they call as row key, and each row may have a number of columns. And you'll be seeing that thing happening, that instead of having individual rows defining, like in a traditional RDBMS, you have if you have an employee object and it has three attributes like employee ID, employee name, and employee age, you store it in one record, or basically one row in a table with three columns. When you switch that concept to a NoSQL database, you will basically store each of the column as an individual row, and you will see that representation coming in. That will make things more clear, that what is the fundamental difference between a NoSQL type of database, and in this case it's particularly the key value type of database which your Hbase is. There are other models like graphical representation and all others are there, which Google and Cassandra and other type of NoSQLs are based off. So even in NoSQL you have multiple different ways in which you can store data. Your Hbase is more around key value type of pairing. Take a look at it. This is at a record level, the structure which you can see from a data perspective. So if you have an individual row here pointing like cutting and clipcon, and you have two different data sets, info and role, that needs to be stored as a group data part. So if this is the representation that you have to represent in a database, if you push this type of data into a Hbase type of system, so these are just the logical record, like this is what will be the picture, that will be the conceptual picture, or what you call as the logical data model. When you store it into a Hbase type of key value pair, this is what gets stored. Each and every attribute becomes a row. You can see here that now you have cutting, and then you have info height, info state. So basically excuse me, all of those individual attributes, if you go back, you can see here that for cutting you have info, and it has these four attributes, height as well as the state. That was something which needs to be stored in a Hbase type of database. This is what gets stored. Each attribute becomes a column. So basically all the columns that you have, all the columns are stored as individual rows, and you will keep repeating it. In that sense, you will have a very high efficient way of randomly accessing the data. Timestamp and everything, these type of things like timestamp, Hbase automatically adds to any insert that you do. So that's an attribute that it will always populate. So there are always a good chances that at least most of the Hbase stuffs will be around, if you look it from a row and column type of thing, so maximum around 4 columns is what the representation will be mostly. So it's a different way of storing the data in a different elegant manner. Does it mean each column family is stored as a different physical object? Well, this view is of the physical view itself. When internally it tries to store, it marks each row, as you can see, cutting, in this case cutting, info height, timestamp, and 9 feet. This is all stored as a group or as a single physical entity in the database, and then you have it sorted also on those individual stuffs. But yeah, the representation or the storage in actual at an actual Hbase level will be at an individual row level. But it might happen that when you are having Hbase stored in a cluster, even if the row keys are the same, like you have two attributes here for cutting height as well as the cutting state. So this might, the first row might get stored on one node, the second node might get stored on another node. But it's unlikely to happen that row key and column key get stored on one row or on one node, and the timestamp and cell value goes on another. So the definition or the entity part or the atomicity of a physical storage lies on an individual record level. And this is where it's storing it. So this should start making sense. If you guys do some more research on NoSQL type of databases, you will see they're mostly key value pairs. But as I said, that you have also other storage forms available. Internally, their storage, you can always, at least Hbase instance inspired around a Hadoop thing. So you'll see that it uses the same type of master server type of concept which your Hadoop is based on. In Hbase, those entities which will be something which we'll be discussing, but this is primarily Hbase you will be using for storage purpose rather than for using any like SQL or that type of thing getting there. Okay. Column family CF is something which you can see that the different sets of column may have different properties and access patterns. So you can define that. You can have compressions defined, because again you are not talking about billions of data, billions of row. It's not millions and billions of rows and all. So you will, even if it's just key value, still if you start counting in that number, you need some efficiency, and that's where your compression comes in. You can do versioning, cache priority, a lot of those things can be done. Hbase gives you a good or a fairly competitive number of features which you get even in your traditional RDBMS. It's just that it's not built up for a typical RDBMS type of interaction. It's mostly recommended to be used for access, random access and large storage of data. That's something which excuse me, it encourages. In terms of the capabilities also, since its primary purpose is to store a good amount of data and give a random access, it gives you many different APIs by which you can interact with it. Java, of course, because entire Hbase again is written in Java. You will see same thing, the jar files and all other things. REST and HTTP, you can have your CURL access as well as the RESTful clients also. You can interact and actually have a Ruby client or any other RESTful way by which you can create tables and things like that. Apache Thrift server is also something which it will support, as well as Hive and Pig. Again, they are there as a front end. As a back end, they can use, you can integrate Hive to use Hbase as a data source apart from or instead of your HDFS tables or HDFS file system. So that configurability can be done. Hbase has been written in a manner that it expects other ecosystem projects to be there so that it can configure and get well along that. These are some basic APIs which you have at Hbase level: get, put, scan, increment, and all those things part. So we will see it when we do the simple installation and some small practice on that. You will see that these are how you configure Hbase, start the Hbase shell, and then create tables and have some data interaction with it. The high level architecture for Hbase will be something like this, wherein Hbase, as you can see, that it just acts as an alternative for your storage of data which is on HDFS, and through Java client, which in turn can be interacted through core Java application or Thrift or REST gateway, as well as MapReduce gateway using either Pig or Hive. You can interact with Hbase and take the data from it. Parallelly, there will be a process. Zookeeper is a very well-known process and an Apache project which talks about or implements the interaction between processes. So internally, the communication that happens between in Hadoop also, your name node, data node, and that type of interaction when processes have to talk to each other across node in an elegant manner. Zookeeper takes that responsibility and does that. Try exploring more on Zookeeper. It's a standard Apache project which is used even at your Hive level and all to do the configuration, to do the communication or take the responsibility of communication between processes which are spread across distributed nodes in a cluster. Hbase, when you are running Hbase in a Hadoop mode, when you want to leverage the clusters member of Hadoop, you will have to also configure Zookeeper as in that sense. But Hbase can be used standalone also without even starting the Zookeeper part. Some of the common terms and daemons that runs or as part of your Hbase is basically in this case it calls now Hadoop calls slave servers or slave processes. Hbase will term them as regions. So it defines or basically creates a subset of your tables row at a partition level, and that's where it calls as individual regions. So if you have if you take a simple example of 1000 rows, so it might create partitions at every 100 rows, and it will store that partition on individual node on a cluster, which it will call as a range server. And also there will be so in those will be the individual ranges. There will be a master region server that will be available. So again, that configuration comes in that you have a master Hbase server, then individual region servers, which are kind of or on similar concept as data nodes, which stores the data. So herein, instead of master and slave, you have master and regions, master server and region server, which do that control to get that particular detail out. Okay, let's go into some other content on that part, and then we'll talk about some of the details. So on a cluster architecture, again, this is there. These are just for your references. That Hbase is used in a very, I'll say, complex environments. You can have small clusters as well as large clusters and all that things, but it's just that you will have to see how much relevance it is and in what particular level it's used for the details part and all. So you can see this is a more cluster type of architecture wherein you have zookeepers running, coordinating with multiple H masters, which are your Hbase master processes, which in turn is having interactions at your region server level. So internally, once you start going into the low level details of Hbase, you will still see that thing coming in, wherein it talks about the low level implementations of how these processes talks to each other. Zookeeper, as we talked about, is something which helps do the communication between your master and slaves and processes which are running individual on your cluster nodes. So at Hbase level, that is you term the H master as your master process, and region servers are your slave process, which are individually having the regions of data, and that communication between them is taken care through the zookeeper process and all. So read about this one, but these are just for your high level reference. You will have to go into more low level details of Hbase to do a admin level understanding, and again zookeeper and other things also comes, which are dependent projects which gets used here in terms of process communication and all that stuff. A big cluster deployment using Hbase will look something like this. It just gives you high level numbers here. You can see. See, these are just some high level numbers or key processes in a part of a big cluster. Zookeepers, secondary name node, HDFS, MapReduce, these are our HDFS thing. But at a Hbase level, because it's used very closely, Hbase and your Hadoop MapReduce, it just talks about some of those details, high level. For a smaller cluster, you will decrease the overall numbers of these key master slave processes which are running in. You can see on top your master process groupings are in the light green, wherein your name node, secondary name node, as well as your other master processes like for job tracker, these are your Hadoop based master processes. Hbase based master processes are your Hmaster as well as Zookeeper. Down below you will see the slaves, data node and task tracker from Hadoop perspective, region server from Hbase perspective. So it depends again the type of business case you are trying to solve as well as the amount of data that you are trying to store in. That's how you will configure these numbers. But the architecture of Hbase internally is pretty much similar to what you have seen at HDFS level, which is in a master slave type of configuration and all. Now these are some important distinctions or comparisons that we see that Hbase, when you compare it with HDFS and all, how are some of those numbers look like. Write patterns, read patterns. You can see that typical HDFS, at least when you are writing, we know that it's only append only, it will never write or allow you to do concurrent writes or random writes, whereas Hbase can do that. It allows you random writes. A read pattern also, the whole scanning happens. And so for that type of thing, Hbase as well as HDFS both have their individual domains of expertise as to what type of business need that you have. It shows it here also, like when you do a Hbase query, HDFS will be more, I'll say, powerful, since the data is in one particular thing in a sequential manner and all. Hbase, of course, since it does it in a random manner, mostly it's a hash based storage that happens, so it's storage in that regard. Whereas read and writes are fast when you try to make complex queries in terms of showing relationships on the data. That's what takes some time, and it stores or at a very high level the range of some data also, the high level things that you have. As you can see that if you have neither random write neither random read, stick to HDFS. So just because you know Hbase doesn't mean that you start using it. The most common use case for Hbase is to have a random read and random write when you know that your data will be in that format itself. It just gives some efficiency. At RDBMS level, these are some of the key things that you are seeing in. I don't think we mentioned there is a tandem. There's not tandem. This is random read and random write. It's not tandem on that part. Compared to RDBMS, these are some of the high level things you can see. In terms of the data layout, as we know that RDBMS is row oriented, Hbase is column oriented. So that's the whole distinction, or at least the category between RDBMS and NoSQL database. And that's something which you will start seeing at individual level. Transactions handling, queries, security indexes. So the good business case for Hbase is mostly for high volume storage and random things itself, and you can distinguish it at HDFS level. You can compare it, as well as you can also compare it at an RDBMS level. So Hbase is not a replacement for your RDBMS. It's just a different type of data storage mechanism. When you compare Hbase with other NoSQL, when you compare it with other NoSQL databases, these are some high-level comparisons that you have in terms of consistency and availability. The good thing is that compared to other databases, Hbase integrates very well with other NoSQL database. Hbase is written mostly taking into consideration the Hadoop-based integration in mind, so it integrates well. Other low-level things in terms of partitions and all, that's something I'll appreciate you will have to refer to your database consultant, and that's where mostly the database skill sets comes into picture. How horizontal partitioning happens, vertical partitioning, or your normal stuffs, those are some things it still stores. It's primarily, it is still a database. That's where the shredding and all that things comes into picture. So you will be seeing that's a common availability common feature at any database level, how you do partitioning in terms of range partitioning and horizontal partitioning and all things. These are some large or some high level numbers which shows the cluster size of what type of data that can be stored. Like you can see that 700 terabytes could be across 700 nodes. Now again, these are all dependent on what type of memory or data that you or capacity that you have it available. Something should be there. These are just some high level number. Now individual experiences might differ, but this is just to give you a high level perspective of what type of cluster and volumes which we are talking about. Reads, writes, milliseconds. It gives you a fairly good number, at least to keep in mind while designing or thinking Hbase as a solution to store the data. HDFS is good, but when you start seeing that your data is very large, even if your MapReduce jobs are simpler, but the maximum time is there in the IO itself, and you have the need to randomly access the data, like first file 1, then file 3, then file 10, then file 2, that type of random access. You might get that type of thing. No, so in that case it might happen that many times when you are doing, suppose, sentiment analysis, and you are getting feeds from different regions in a random manner, and you have stored that in a random manner. So in that type of cases, if you want to do sentiment analysis, your MapReduce logic is not going to change. But if you try to store it in HDFS, it will be very inefficient, in the sense that every time, since your data for one analysis or one block or one specific criteria, like suppose you want to just store or analyze the data for a specific state, and you know that the data from that state has come in a random manner, and that is how you have stored it. So in that case, if you have stored it in HDFS, to do that analysis, even though your MapReduce jobs are efficient, you will have to go through multiple different times here and there. It's not in a sequential manner and all. But if you store it in Hbase, it will be far more efficient, because it typically does it in a hash manner. So it will be able to fetch that data, or it basically decreases the overall IO time drastically. But yeah, all these are for reference number, as I mentioned. When you go and do that analysis, have this technology in mind, high level architecture and all that stuff. But that's where your database folks can take it to the next level, since you know already Hadoop and all. Going more deep into Hbase will be easier. Okay, now some key guidelines of when to use Hbase. It says that when random reads and random writes are there, either you need both or either of them, it helps. You need to do thousands of operations per second on multiple terabytes of data. So that type of volumes are we looking at. as well as your access patterns are well known and simple. So you want to simple add a value or update a value. You don't want a complex query that where this is equal to this and that is equal to this, then do this. When you have complex computation to put on data set before you make any changes, Hbase is not that good kind of guy, because Hbase primary job is to store and give you easy read and write. It does not gives you a very elegant and a strong processing capability. You can combine Hbase with Hive. In Hive you can write Hive QL and put that queries, but that again might not give you the best elegant system. So take your priorities, look into it. Hive and Hbase integrations does work fine. It's just that you need to do a good balance between it, that if you see that your uh, logic is also complex as well as you need random read writes, then probably Hive and Hbase will be a compulsion. Otherwise you can go for other storage and other type of choices. Do not use Hbase when you can see that when you only append to a data set and tend to read the whole thing. So mostly if your nature of interactions are sequential in manner, you don't have to go for something like Hbase. You can see that you primarily do the ad hoc analytics, as well as you data easily fits on a specific node, so you don't have high volumes. You do pretty much uh, sequential type of interactions and all, then Hbase might not be a good solution. Although Hbase can always store the data internally, it's just that you have to look for a better business case to get the best out of it. So this was an introduction to Hbase, some of the key terminologies that it has, the components that it offers, the key APIs, as well as also in a cluster mode, how it integrates with Hadoop, at least the high level cluster numbers, the master and the slave process and all. Some of it we'll see once we configure Hbase, just to get a understanding on this particular part. Thank you for this session on Hbase. In terms of its installation and configuration, very much similar to its other counterpart projects that you have, Peg and Hive, simple tar file based configuration. Try to use something more stable. December 3. You can choose any one of it. We'll just choose the 0.94.3 version. As with all other components, just download the tar file, save it locally on your file system. Starts the download. Once it loads it locally, we'll just try to set it up and have the interaction. As you can see that it downloaded that particular copy. Let's close this up. Let's open our terminal. This is where it has downloaded that copy, Hbase 0.95 tar version. Now we'll at the Oracle home level, I'll just create a directory. And I'll just copy that particular tar file into this particular folder and unzip the same. If you do ls, it just unzips the whole file. Now go into that Hbase directory. You'll see the distribution is very much similar to, in terms of the packaging, same as that of your other installations of Hadoop, Pig and Hive. Go into your bin directory. You'll see the existing script files for individual process levels. You'll see the region servers getting their status. You have Ruby skills, so everything that are with RB are Ruby scripts. You have for starting and stopping Hbase, you have these scripts available. We'll use them. If you want to go in a more complex master server type of configuration, all these files needs to be configured. For memory and all related stuff, you have the Hive, Hbase config sh and other files. You will have a corresponding conf file. We will be modifying the HDFS, hbase-site.xml file. This is where we'll have to configure the local directory which we want Hbase to use for storage of the tables and all. That's something which we'll configure here. So to do that, let's go ahead. And as I said that, yeah, for apart from conf and bin, for writing Java related specific things, you will use this jar file which is available at the direct binary level itself. So I've sent you some Java examples which you guys can use to write simple Java based client, assuming, or first you will have to create your tables in Hbase, and then you will use the Java based program to update or access the data from that tables and all. So that is where this is Hbase jar needs to be added in your class path in Eclipse or any IDE, and then you have all the individual classes and all coming in. So let's go actually at home Oracle level, and at this level I'll just create a temporary directory which I will specify. This is the temp directory. We'll go to Oracle Hbase, and this is what I'll specify as Hbase root directory to keep the data that it wants to put in. cd into conf. Okay, cd Hbase, cd conf. Now let's open your Hbase site XML. Go down. You can see that pretty much has the same syntax as other processes or in Hbase on Hadoop, as you have seen. So add these two properties. This property is your Hbase root directory. This is the base one which it will use, hbase.root dir. Corresponding to that, you should have a value as well. This we can put it as home Oracle / temp. This is something which we can configure it here. Should be a good one. So let's check the settings. Property, no typo. Just make sure that you don't have typos. We have seen that it creates issue later on once you get the details there and all. So write and quit. So this file you have cat is all set. Let's check if we have Java available, because it will require Java. So Java and all is also available, root directory and all thing is added to it. Let's try to go and start the Hbase shell. Go pack cd into bin and dot slash start hbase.sh, exactly similar to the way you have it. Okay, it says here that prop element bad element starting bad count file element. Okay, let's check that thing. We have to have a property configuration. Think there is any mistake. Should be running fine here. Configuration, then property. Oh, okay, just you have actually there is a mistake here. These are all under name value, not property thing. Slash name and then you close the property part with a closing bracket. So you have configuration, property, inside that name, close name, value, and all this. Do a right hand quit, go into your bin, start Hbase. Master process is render slash stop Hbase. I think it did start it, but in a corrupted mode because property and all was not available. So this is where it will just stop it and it will should start it again. Once it starts up, all you have to do is you have to just invoke the Hbase shell. So we are at this level. Go back. You can just put bin slash Hbase and this time just call for the start the shell. This will start something. You can see the Hbase shell, very similar to your pig shell, hive shell, as well as the pig shell, the grunt shell, as well as the hive shell. Hbase starts, type help, it will give you the different options that you have at very high level in terms of some common configurations that you can do it here. You can, in order to create a simple table, because you will be creating here mostly key value types of tabular and all interactions. So you can do that. You can create a simple table like Hbase does not gives you high or elegant query language. It gives you simple way to create a table and have data stored and all in it. So let's suppose we create a table called info with a column like name. So it creates this particular table. If you want to take a look at this table, you just put list and then have info. Should be able to give you the details that this is what your table contains and all. So likewise, you can put use the put as well as the get API that will be able to give you the details and all, by which you can add data and get some details in it. You can get the particular thing, and once you have to come out, you can just simply use exit. And it's always good to, once you come out, to stop the Hbase thing That's something which it will be there that stop this database running on all that part. So have this installation done on your system. I'll be sending the video for the same so that you can do it elegantly, and then let me know if you have any questions.